Hi guys, welcome back to my YouTube channel. In this video, we are going to see about a simple electrical transformer. Let's start. Here I have taken a transformer. This is a single core transformer because both primary coil and secondary coils are wounded in the middle. But the working principle is same. You can see it will be very heavy because of iron core. Here you can see some insulating material to reduce heat loss. Actually, transformers are 100% efficient because the power input will be equal to power output. But still there might be some heat loss, so around 99% efficient. First main point about transformer is transformer only works with alternating current. Transformers are used to step up or step down the alternating current. It means input will be alternating current and output will be also alternating current, but we can increase the output voltage or we can decrease the output voltage, but both input and output voltage will be always alternating current. One end of the transformer is connected to alternating current, so that is the input voltage of this transformer, and output is connected to a multi-tester to check the output voltage. Please do not try this at home because it is highly dangerous. Transformer only works with alternating current, and also the input will be also alternating current and output will be also alternating current. So it is highly dangerous. Please do not try this at home. One end of the transformer is connected to the alternating current, that is main supply. So that terminal is known as input voltage. Approximately 220 volt to 230 volt input is coming to this transformer. Now we are going to check output voltage of this transformer and we will decide whether it is a step up or step down transformer. Let's observe. So I keep this voltage, this is alternating current symbol AC. I am going to switch on. Input will be 220 or 230 volt and output we will check. Now you can see the output voltage of this transformer is 13 volt alternating current. So input is 220 to 230 volt and output is only 13 volt alternating current. So it is a step down transformer. Let's see the detailed working principle of a simple transformer with the aid of a diagram. So here you can see a diagram of a simple transformer. I will try to explain in a easiest and simplest way of working principle of a simple transformer. Here you can see primary coil this side and a secondary coil this side. In a transformer, the input coil is known as primary coil and output coil is known as secondary coil. Please remember that it won't be always primary coil in this side. In the exam, sometimes they may give input coil in this side also. Sometimes the input will be given here and we have to take that is primary coil, and sometimes output will be taken from this end, then we have to consider that coil is secondary coil. So for this diagram, this is the primary coil, this is a secondary coil. The purpose of the transformer is to increase the output voltage or to decrease the output voltage. In this diagram, you can see the input voltage is 12 volt AC and the output voltage is 6 volt AC. So here the output is less than the input, so this transformer is a step down transformer. Suppose just if I change this secondary coil as primary coil and this primary coil as secondary coil, means this one will be the input voltage 6 volt and the output voltage will be 12 volt. In that case, it is a step up transformer. So hope you are getting. The first main concept about the transformer is transformer only works with alternating current. I am going to explain how does it works. Right. Now you know about the coils of a transformer. Here the core of the transformer is made of iron or mu metal, because iron is a temporary magnetic material. Please remember, in the input coil, electromagnet principle will take place, and in the output coil, electromagnetic induction principle takes place. So, change in one side of the coil makes a change in the other side of the coil. So, this transformer works as a mutual induction. Okay, let me explain. I think you are very familiar about electromagnet. So, electromagnet works as a temporary magnet. So, iron is the temporary magnetic material, and we wound with a copper coil and we connect to a cell. When the current flows through this copper wire, it induces magnetism in this iron, and this iron become a magnet, either this side north and south like this. This is electromagnet. Instead of using this DC, when we use AC, what happens to the poles of this electromagnet means current direction keep on changing. So first, if north here, south here, then next south, then here north, then north, then south, then south, then north. Like this, the poles will keep on changing when it is connected to the alternating current because of change in current direction. So the same principle is used here, this side. Here, this is the primary coil, that is the input coil. You can see the input is connected to alternating current. When the current flows through this coil, there will be induced magnetism. Because of alternating current, this magnetic poles keep on changing, south, north, then north, south, then south, north. So here electromagnetic principle take place, but the poles will be keep on changing because of change in current direction. So suppose this is north pole. For our learning purpose, it is connected with the iron core. So you all know that there will be magnetic field from north to south. So the magnetic field will be passing from north to south. So here copper wire is there. When this end become north, then magnetic field from north to south will be passing, and that magnetic field will be cutting this copper wire. So here electromagnetic induction principle take place. As you all know, when a conductor is being cut by the magnetic field lines, it induces an EMF in the coil. That is electromagnetic induction. So first, when this end become north, the arrow will be going and cutting like this. Suddenly this end become north, then the arrow will be going in this way and they will be cutting like this. So this way and this way and this way and this way. So the magnetic field lines, that is change in magnetic field lines, keeps on cutting this copper wire, and there will be again induced EMF with a change in direction. So that is alternating current. The induced EMF depends on number of turns on the coil. So here the number of turns is 5. So the induced voltage will be less. You can see here 10 turns, voltage is 12. When we reduce the number of turns into half, so the output voltage will also become less. I hope you got it. Here is the diagram. You can see, you can assume this both. First field will be going and cutting in this way. The next the field will be going and cutting in this way. So it keeps on changing and cutting this copper wire. You can see the direction. First this way, then this way. This way, this way, this way, this way. Like this. The change in magnetic field keep cutting the number of turns in the coil, and there will be induced EMF with a change in direction because magnetic field lines keep on changing. I hope you are getting. Let me conclude. Primary coil electromagnet principle is used, and in the secondary coil electromagnetic induction principle will be used. So there is one equation of a transformer. Output voltage divided by input voltage equal number of turns on the output coil divided by number of turns on the input coil. Here V2 divided by V1 equal N2 divided by N1. This is the circuit symbol of a transformer. Let's try few questions from transformer. Try this first question. The diagram shows a simple step-down transformer used to decrease a voltage. Which part is the primary coil? Your time starts now. The correct answer is D, because it is a step-down transformer. For a step-down transformer, number of turns on the primary coil will be more than the number of turns on the secondary coil. So, in the diagram, this part, that is D, is having more number of turns. So, D is the primary coil. Try this second question. The diagram shows a simple transformer. From which material should the core be made? Option A, aluminium. Option B, copper. Option C, iron. And option D, steel. Your time starts now. The correct answer is C, that is iron, because iron is a temporary magnetic material. Try this third question. The diagram shows a transformer. The input voltage is 240 volt. What is the output voltage? Option A 6 volt, option B 12 volt, option C 20 volt, and option D 40 volt. Your time starts now. The correct answer is B, that is 12 volt. Let's have a look at into the calculation part. The transformer equation is V2 over V1 equal N2 over N1. In the question, we have to find output voltage, that is V2. So let's rearrange this equation according to V2. we get V2 equal V1 times N2 over N1. N2 is number of turns on the output coil, that is the secondary coil. So N2 is 40 and N1 is number of turns on input coil, that is primary coil, so 800, and V1 is the input voltage, that is 240 volt, and by substituting the values we get V2 equal 12 volt. Try this last question. The diagram shows a transformer. Which row describes the magnetic field in the soft iron core and the magnetic field in the secondary coil when the transformer is operating? Your time starts now. The correct answer is A, because when the transformer is operating, the magnetic field in the iron core and the magnetic field in the secondary coil keep on changing. I hope you got something about a simple electrical transformer. Thank you.